In today's lesson, you're going to have a chance to practice some of the inner joins that we worked on in our previous module. This is a pretty meaty lesson, so this one lesson is going to be the whole module, and it's going to take us about 23 minutes. Let's get started. We are going to do this do-it-yourself problem a little bit different this time from how we've done it in the past. In previous modules, I've kind of been spoon-feeding exactly what to do and how to use each step and how to complete the problem. In this lesson, I'm going to give you an opportunity to kind of see a little bit behind the curtains. How did I come up with these instructions? How are we going to convert a business question into a SQL problem? And then how to break that up by steps. And moving forward, we are going to continue doing all of our do-it-yourself examples in this format. And then by the end of it, you're going to be completely on your own. So we are going from, the bike without the pedals. Now we have bikes with pedals and some training wheels, and pretty soon we'll be without the training wheels. So the business question that we have is you want to know the difference in the size of San Francisco bike riders to New York City bike riders in 2018. So we want to compare how many riders that we had in 2018 in San Francisco, compare that over to New York City. We also want to know if there are any differences by the gender of the rider. And just to be clear, this is the self-selected gender that the riders have applied when they sign up for the city bikes. So my question for you is, how would you solve this? What I want you to think about is, how would you go about trying to answer this question? What type of math might you use? What type of comparisons would you want to look at? And if you feel completely stumped, what I would suggest is imagine that you are the business person and you ask this of your data analyst. Hey, I want you to compare San Francisco to New York City. What kind of information would you need in order to make a business decision? Maybe the business decision is, how many bikes should we invest in each city? Maybe you want to know, how is the performance from San Francisco compared to New York City? Different things like that. So pause the video, just kind of think about this a little bit. Maybe if you want to write it down, jot it down somewhere. And then when you're ready, we'll come back and go through how I would approach this. So this is how I would break down this problem. First, I would think about it very methodically. What pieces of information do I need in order to solve this problem? First question is, how will you make your comparison? And this is kind of where I left you off in the previous slide. For me, I would say, what is the percentage each city makes up of all of the riders? So basically, if you want me to compare, hey, Candace, tell me a little bit about San Francisco and the New York City bike trips. Tell me a little bit about it. The first thing I'd probably go to is say, well, I want to know, out of all the riders between New York City and San Francisco, how big is each pie? Is it a 50-50 split? Is it mostly New York and a little bit of San Francisco? What does that look like? So that's what I mean when I say the percentage each city makes up of all of the riders. 2, the next thing I'd think about is, what is the data that I would need in order to answer this question? That's pretty simple. We need our city bike trips, one for New York City and one for San Francisco. And then I would want to think about, I'm going to use these two data sets and I'm going to find the total number of riders by gender for each city. Because not only did we want to look at just all of the riders, we also wanted to split it by gender. And 3, how will I get this all into one table so that I can do my analysis? So already, if you're thinking ahead, we have 2 different data sets with similar types of information. If we want this in one table, we're going to have to do some manipulations and eventually join it together. And for this part, this is where I would write out the steps. So all of the instructions that I've given in the previous do-it-yourself problems, these are literally the steps that I would take in order to figure out this solution. Okay. So for example, 43, we want to find the total number of riders by gender for 2018 in both San Fran and New York City. I'm putting in some guardrails here. If the gender is missing in either New York City or San Fran, you want to replace that missing or that null value with unknown. And this will be helpful when you're doing your joins and your analysis. I'm going to ask that you put each city in a CTE. You label one New York City, you label the other one San Francisco or San. After you do that, join the 2 CTEs together. And just a note, make sure if you are joining on any text or string data that you're applying your upper. So if you remember from our previous example, if the case doesn't match when you're joining on, we joined on station name, if the case doesn't match, then Google BigQuery treats those as, no, those are not equal. So a workaround for that is that you just always say, well, just make all of the text data uppercase, and then I don't have to worry about that. Once you do that, you want to find the total difference in the San Fran and New York City writers. So just like a raw number, I have 1 million New York City writers, I have 200,000 San Fran writers, the difference between them is 800. And then the last piece, this is how I would look at analyzing this data. What percentage does San Fran make of all the writers? And this is the math formula that you would use for it. So your San Fran percentage, it would just be your number of San Fran writers over the San Fran writers plus the New York City writers. If this math, you're kind of like, well, how did you get that? And that gives you pause. That's okay. Don't worry about it. That just means that you need a little bit more attention applied to some of your basic mathematics, but that's a little bit different from coding. So coding's one thing, mathematics is another. Data analytics combines both of those. So this class, we're just focusing on coding. In future classes that I'll be creating, we'll focus more on that data analytics portion. Okay, so now that you have this, go ahead, pause the video, and do your best and see if you come up with an answer that looks reasonable. And another bonus is if you came up with some metrics that you're interested in that is not what I have, the percentage or the difference, go ahead and add those in too. That would be an interesting question to look at. Welcome back. I hope that wasn't too difficult. Let's open up that BigQuery console and solve this together. So this is how I would break down this problem. And if you notice, this is a very similar format to how we did the previous example where we were looking at New York City bike trips and the New York City bike stations. So first I have it broken up into step 1 and step 2. And I have this separated with this dashed line because this is one table and this is another one. So in part 1, I'm just going to find all the trips that occurred in the city bike trips in 2018 by gender for New York City. And then, just like before, I'm going to identify the level of the data for this query. Part 2, I'm going to repeat that, but instead of looking at New York City, we're going to be using the San Francisco data. And then again, I'll identify the level of data for that. In part 1, I'm going to label that New York City, and then part 2, I'm going to label that San for San Francisco. Part 3, identify which columns match between query 1 and query 2. And what I'm really asking here is what is the level of data between these two where they're both matching? And that's going to help determine my joining columns. Part 4, now I'm going to put these queries that I've already drafted in my separate windows, I'm going to drop them into CTEs. NYC, San. 5, I'm going to join on the similar columns that these CTEs share that I identified in part 3. Step 6, calculate the difference in the total writers of New York City to San Francisco, and then calculate that percentage. It's really important that before you even start the problem that you have your instructions laid out like this. Otherwise, you're going to get lost in the sauce and it gets really confusing. Okay, let's start with New York City bikes because we are very familiar with that table. So I have my select, my from. I'm going to do extract year from start time as year. I have gender and then count star as total writers. We only want 2018. So we want our year to equal 2018, and we're going to group by 1 and 2. Okay, so this does not have any missings or null gender, which is good, but I also see that these are all lowercase, and I'm going to go ahead and just convert this into uppercase. Okay, let's take a look. Okay, great. So I have my year, my gender, my total writers. And I'm going to call this, instead of just total writers, I'm going to call it NYC writers. That way, when I'm joining my tables, I'm not getting confused as to who's who. Okay, so now one is done. Put him to the right. Now I want to do this again for San Francisco. Now, San Francisco, even though these are both city bike data sets, the information is a little bit different. So I have something called trip ID, duration by seconds, start date, which this looks like our start time that we had in the New York City, and then we have station name and a bunch of other stuff. Okay, and then let's look at gender, because that's the other thing we're interested in. And here we see that this column is called member gender, not gender. So that's something where it's like, that's so frustrating. Why don't they just call it the same thing? These are both city bike trips. In the real world, this is how it goes. So you as the data analyst, this is part of the value that you add, being able to identify that member gender is the same thing as regular gender. Okay, so we're going to do extract year from start date. I believe that's what it's called. Yep. As year, member gender, and I'm going to rename this gender so it matches my other table, and then count star as San writers. And then we're going to do the same thing here, where the year equals 2018, and then group by 1 and 2. Forgot a T, run it again. Okay. So now I see something interesting here. Now I have something called male, other, female, and null. So in my San Fran data, I have technically 4 different classifications because we're going to do a conversion. We're going to say if you're missing, we're going to put you as unknown. We also have something listed as other. In New York City, we only have unknown, male, and female. So that's something interesting to think about. Why would that be? It's hard to say. One thought that you could have is maybe San Francisco was a little bit ahead of the time and they said, we want people to be able to select something that's not just your standard binary male, female. And so they introduced other. Whereas in New York City, they said, if you don't want to put that, you can put unknown. Maybe that's how they treated it. We don't know. So we need to make some adjustments here. One thing is that we're going to go ahead and make this capitalized. That way it matches our New York City data. And then the other thing is we're going to get rid of this null and we're going to turn it into unknown. So we're going to leave gender there, and then we're going to say if member gender is null, then unknown. Otherwise, leave it as it is, gender member, as gender adjusted. And let's compare. Oh, I need to group by one more. Okay, so now I see with my gender adjusted, null, he's been turned into unknown. But I still have this issue where these are these are camel case and I want them all uppercase. So all I have to do is apply upper, run. Okay, so now I have male, other, female, and unknown. And when I'm looking between my 2 tables, I can clearly see which columns are matching. We see we have year. We also have the gender adjusted. If you didn't do the if else, you could have also done a case statement. That's another way to do it. That would have looked like this. Case when member gender is null, then unknown. Else upper member gender, and as member gender adjusted to. And we'll get rid of, well, we'll leave it there. Okay, so we have the gender adjusted, we have the member adjusted to. You see, these are the same thing. Same thing. So I could have done this if else. If it's missing, if it's null, then unknown. Otherwise, member gender, make the whole thing uppercase. I could have also done case when member gender is null, then make it unknown. Otherwise, else, make it the uppercase of the member gender. Okay, we're getting into the weeds a little bit. We're going to leave it here. Okay. Okay, so we didn't identify the level of the data, but I kind of already gave it away. Level of data is at the year and gender level. Oh, and I'm going to change this so it's just this gender. The level of this data, is at the year and gender. Okay. And when the level of the data is exactly the same, that means our joins are just going to be at whatever this level is. So we want to know for year 2018 by gender, how many San Francisco writers you had and how many New York City writers you had. Now that I have my pieces, checking here, I've already done 1 and 2. I also did 3. Now it's time for step 4. So I'm going to say with NYC as, and I'm just going to drop them in here. Okay, I'm going to tab them in, collapse it. I'm going to do enter, comma, San as, same thing here, copy, paste, collapse it, join on the similar columns. Select star from NYC, inner join San on NYC.year equals San.year. And NYC.gender equals San.gender. And let's run it. Now you notice here, I get year, gender, New York City writers, year, gender, San Francisco writers. That's because I said select star and I said give me everything from NYC, give me everything from San. And so it literally just did that. It just went boop, right to the side. If I didn't want these things to be repeated, I could have just done this. I could have done using year, gender. Using requires that we name the columns exactly the same thing. Okay, so when I do using, BigQuery knows, oh, year and gender, when you're doing the select star, you really only want it one time. So then we have year and gender. And then the last way we could have done it is just said nyc.year using our dot notation, nyc.gender, and then nyc.nyc writers, and then san.san writers. So this is another way we could have done it. Okay, so now that I have joined, now I need to calculate the difference in total writers of New York City to San Francisco. Now I could just do, what if I just did san.san writers minus nyc.nyc writers as writer diff? What would happen? I get a negative number. Sometimes this doesn't make sense because if I just say, oh, the writer difference is minus 365,000, and you might be like, maybe I know that. Maybe I'm like, well, it's the difference. So like, what are the total number of writers? What is a negative writer? Maybe I don't like that. So what I could do is I could just do absolute, and that just flips the sign. And it just says, if you're negative, we're going to make you positive because we're talking about people and we don't have negative people. We only have positive people. Okay. And then, so then when you're explaining this, you say, well, the difference between New York City and San Francisco writers is that there are 420,000 more writers in New York City than there are in San Francisco. Now, you could have also just said, forget this. I'm just going to subtract the big number from the small number. That's fine too. Or you could have left it as negative. That's also okay. It just depends on how your people are going to interpret the data and how you want to explain it. Okay, next part, we want to find the percentage difference. So we always do safe divide whenever we do division because we want to preemptively make sure that we get rid of any errors. So we want to look at the San Francisco writers over the San writers plus NYC writers as percentage. Sam. Okay, and I didn't say this, but these numbers, they're really small and they go for a long time. So that's, it's kind of confusing for me to look at it very quickly with my eyes. So I'm going to do a round. We're going to round this to 4 decimal places. And then if I wanted, I could just do a copy paste. And instead of looking at how many San Francisco writers make up of the whole pie, we could do New York City writers. And there you go. And if we add these two numbers up, they're going to equal 1. And that's because we're saying out of all the writers, 93% for unknown are in New York City. And then 7% are San Francisco. If I look at men, I see that out of all the data that we have, out of all the men who've been riding these city bikes, have been making these city bike trips in 2018, 93% have come from New York City and 7% came from San Francisco. And then I see the same thing with women for females. And the percentages are a little bit different, but in general, what I could say is that if I'm looking at the whole market, San Francisco makes up about 7% of the entire market for the city bike trips. And I can see that because no matter how I look at it, it's not like there's a lot more women that are riding in San Francisco than men. It's the same ratios. Let's jump back to the PowerPoint and wrap up this lesson. Today's lesson, we introduced how to break down a business problem and convert it into a SQL example. And this is the method that we're going to be using throughout the remainder of this course. In the example that we did, we practiced our inner join, group by, our conditional formatting, our formatting functions that we did with round and our uppercase, and we also performed some basic data analysis. Next module, I'm going to do just more examples of joins because you really want to get this down under your belt before we start looking at different types of joins. See you there.